So now we're going to go backwards here. That is, find the value of z that corresponds to a given area. So this particular example, we're going to find the value of z that corresponds to the 85th percentile of the standard normal curve. Again, step one, always draw and label a curve. I'm pretty good at these, and I still do this on almost every problem. So the 85th percentile is, we have this area here. The area is 0.85. So we're going to be looking in the body of this table for 0.85. Well, not 0.85, right? Because our table gives us from 0 up to some value. So really, we can remove this 0.5 here. In our table, we're going to be looking for 0.35. So look for the value of 0.35 in our table that corresponds to some value given down here. And so there's the closest one that I found, 0.35083. You're really going to get it exactly on the value. And then look over to the left, we have 1.04. So that is our value that would go here, 1.04. Most likely, you're going to be using technology to do this. So again, let's draw this out. Okay, so again, access the distribution menu by pressing second vars. Select inverse norm. Now we're going backwards. Before we were selecting norm CDF, now we're going to be selecting inverse norm. We put in their area. Now for the calculator, it goes all the way. Its sort of model would be like this. It's finding this value right here. It's finding everything to the left of this unknown value. And that's what it's going to give us. So we can actually put in 0.85. We don't need to put in 0.35. And then put in the mean, put in standard deviation, select paste, and you'll get 1.04, the same thing we obtained by using the table. Using the older model, you do the same thing. You go to inverse norm, but you have to know that syntax. And again, the syntax is area, mean, standard deviation. Let's look at one more example. Example 5 here. This time we have the normal curve drawn and shaded and are asked to find the z-score that corresponds to the given area, 0.9332. But this time it's shaded to the right. So as usual, there are a couple of ways to determine this. So we're going to use the inverse norm function to find the area. But note that the syntax of the area gives the corresponding when shaded z-score when shaded to the left. Recall that our model for the calculator is the value shaded to the left. So we need to know this value right here. So we need to know this shaded area right here. I'm shading it in yellow. So that's the value we need. Well, we know that these two areas here, the red and now the yellow, need to add up to 1. So I just need to subtract 0.9332 from 1. And that's going to help me find this value here, somewhere between -1 and -2. So 1 minus 0.9332 is 0.068. Again, think about what we just found. So this 0.0668 is this area here. 0.0668 is that area, that yellow spot that I just shaded in. So that's the value that I need to put into my inverse norm, 0.0668. And I'll get about -1.5. So that would be the value that goes there. That looks about right, right? It looks like it's right in between -1 and -2. Now the older model of the calculator, very similarly, we're going to go ahead and subtract 0.9332 from 1 and put that corresponding value into the inverse norm function. Now another way to do this is to sort of take advantage of the perfect symmetry that occurs in the standard normal curve. And we can just go ahead and put that 0.9332 in for the inverse norm. We get positive 1.5, and we know that it's just the negative of that. But be careful. And make sure that's why we always have these curves drawn. This one was given to us in this particular case, but always draw these curves out and make sure that your answer makes sense. So after I got this, I looked at that 1.5. Well, that doesn't make any sense. It's not 1.5. Wait a second. It's the opposite of that. It's -1.5.